Hello, everyone, and welcome to today's SANS webcast. Most used AWS services and how to use them securely. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Jonathan Kirby, Cloud Security and DevSecOps Consultant with JKirby Security. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Jonathan.
Thank you, Carol. Appreciate the introduction. All right. Good afternoon. Welcome, and thank you for joining me to most used AWS services and how to use them securely. Again, my name is Jonathan Kirby, and I'll start off by telling you a little bit more about myself and who I am. I'm a leader, an instructor, and a mentor. I like to say that I practice cloud security, DevSecOps, and all things human security, versus saying things or that these are the things that I do or what I am. I like to say that I practice them because, like all great professionals, whether athletes, artists, or performers, they are constantly learning new skills and practicing their craft in efforts to always be getting better. Also, doctors practice medicine, lawyers, they practice law. I'm not saying that I'm on the level of a doctor, and I'm certainly not a lawyer, but I do consider the security industry to be among the top professions out there. And it is an adversarial field. Also, I know the level of effort, learning, practicing, and always trying to get better than the threat actor that goes into what we do. Or if you're on the offensive side, you need to be better than your target. And you probably also need to be better than your competition as well. So because of this, I say that I practice security. So the shorter elevator speech version of that is I help teams build security into their processes, workflows, pipelines, and their culture. As a cloud security engineer, I get to work with software engineers. I help cloud architects and engineers build more secure infrastructure and monitoring for their infrastructure for performance and security purposes. And I also get to work with the business, especially the leadership teams, to help improve our overall security, the enterprise security and risk posture. A little insight into me personally. I'm a really big fan of Cobra Kai since it came out a couple of years ago, and a general fan of the whole Karate Kid franchise. I say that because I seem to have made a decision recently that I kind of want to learn everything that I possibly can about leadership, cloud, and cloud security, and all things DevSecOps. And then I want to share all that knowledge with the next generation of security professionals and also the community with all of you. So with that, let me start by saying thank you for joining me today. And I hope that some of the things that I talk about today you find helpful and useful. So today, high level, we're going to talk about some of the most used AWS services. We'll take a high level look at what are these services, recommendations and best practices for how to use the services securely. And I'll also touch on the respective CIS AWS Foundations Benchmark recommendations. Why CIS, you might be thinking? Well, because it's a good organization or a good set of controls to base your security program on. It is an industry recommended control framework, and CIS has done a great job in this area for the community and excellent foundational benchmarks for hardening your AWS and other cloud environments for that matter. They don't stop at just AWS is really what I'm trying to say there. Also, point of note that I am or will be referencing to the version 1.3 of the benchmark recommendations. There are a few previous iterations or versions. So if you're thinking like, hey, some of these don't match up to what I've seen on my previous PDFs, that's okay. It's understanding. Another great thing about CIS is as a community, we're always looking to improve and stay current with what's going on in the industry and the threats that are out there. So we want to make sure that they want to make sure that they're always putting out the best possible material and collateral and best practices for us. Also, again, these are foundational recommendations. So like the name says, foundational. Please feel free to continue to explore beyond these recommendations for your specific use case. I say that a lot because everyone's business use case is going to be different, and best practices are just that. They may be widely used in the industry, but they are not one size fits all and can not always applicable in every single scenario. So we need to be thought leaders and professionals to make sure that we're applying these practices appropriately for what we need. So let's start off with AWS IAM. So what is it? IAM is AWS's Identity and Access Management Service, IAM, or IAM as we like to call it, IAM. It allows you to securely manage access to AWS services and resources. And this is where you create and manage your AWS users, groups, and roles, groups for role-based access control. We'll get into a little bit more of that here in just a few minutes. And then it's also important to keep in mind or to note that IAM uses permissions to allow and deny access to resources. So you can get very granular if you choose to. So there are quite a few best practices, security best practices for IAM. It's a pretty important service, obviously, since it controls the access to all of our stuff. Here are just a few of my favorites. First off, don't use root. There are very few services or actions that require you to log in as the root user, so just don't use it except for those specific use cases. Set up an identity and access management scheme, create your users, put them in roles, and manage permissions at the group level. This is no different than any other system or vendor application that you would harden. And the first thing you do is disable, default control or default accounts, etc., stuff like that, similar in nature. You'll also create individual users and put them in groups, like I just mentioned, and then assign permissions to the group, not the individual. Also, don't forget to use least privilege when creating policies and assigning permissions. Focus on the group level versus individual controls or managing permissions for individuals. The sprawl can get out of control really fast. So focus on the group. You have developers, you have engineers, you have business users, whatever those groupings are, and then give permissions that they need for that group to do their job. No more, but no less. Give them what they need to do their jobs efficiently and effectively, but they don't need access to everything. Also, configure strong policy, strong password policy for your users. There's a section in Identity and Access Management for creating a password policy. Use it. Make sure that that it at least meets your corporate password policy, because again, it's not a good idea to have your corporate password policy up here and your AWS password policy down here. You want to make sure that it at least meets your corporate password policy. However, feel free to exceed. That's okay. I don't think anyone's going to tell you not to exceed your minimum corporate password policy. Things to consider. And make it stronger. Again, we're dealing with the public cloud. We don't have 100% control over the resources anymore. So these are public, they're accessible over the internet. We need to be more deliberate in our configurations and permissions. Also, follow AWS Foundation Benchmark recommendations is an excellent place to start. NIST has excellent recommendations as well. They've put out totally revamped password policy recommendations within the last couple of years, focusing very much on long and strong passwords, being user-friendly, easy to remember, different things like that. Find some combination of both. If you don't know where to start or you haven't created one yet, these are good resources. Again, best practices and resources to lean back on. On the side note, if your corporate password policy does not meet the same level of strength as either NIST or CIS, you might want to consider updating your corporate password policy to be a little stronger if you don't feel it's as strong as industry recommendations. Another one, force MFA. Again, anytime a system provides the users to enable and use multi-factor authentication, I highly encourage this to be not just enabled, but also forced or enforced. So anyone logging into the system is required to use multi-factor authentication. That way, if their password gets compromised, you still have a second layer of control. Again, defense in depth. Assume at least one or two controls may fail, and you need other protections. Again, that's a good part of the security program. But enforce it for everyone. All of your users, if you're logging into the if you're logging into the AWS Management Console, force them to use MFA. And for the root user, even go further and require a hardware-based MFA key versus a software that you might have on your mobile phone or something. And then lock that hardware key in a safe somewhere that only a select few of people, a select few have access as part of your business disaster recovery plan. Again, the root keys access everything to your accounts. If those get compromised, if your root account gets compromised, you may lose control of your account and may never be able to get it back, or you're gonna have to go through a whole lot of hoops, and it just won't be a good few days or longer. That's just a thought. That level of control, locking away the root key in a safe or something like that on site, or maybe off site, maybe you have bank vaults or different things, it just depends. It may or may not be appropriate for your environment. I can't answer that question for you. But what I would say is check your risk assessments. Maybe do a business impact analysis if you need to, and then make a decision based on what you believe is most in line with your organization's acceptable level of risk. Understand what could possibly go wrong. What are the bad things that could happen if your root account were compromised? A couple more here. Use roles for applications that run on AWS EC2 instances. Use roles. Also, use roles to delegate permissions instead of setting up IAM users for service accounts. I've seen this time and time again. In a legacy environment, we're used to using service accounts on our systems to give persistent access to different things. And then when we transition to the cloud, what I see is we create those same service accounts, but as an IAM user, just like any other user on the account, like me or the engineers or otherwise. Not recommended. What is a better practice, a best practice, and highly recommended in those cases is to use roles. That way, again, it's not another user that you have to worry about. And there's there's several additional security benefits to using roles with auto rotation of access keys. You just don't have to worry about managing the access keys anymore because it's handled by the identity and access management. It's handled by IAM. Couple more. Sorry. Rotate credentials regularly for your IAM users. That's a big one. Make sure you want to have a good rotation policy. Rotate the credentials and access keys. If you can automate this process, I would highly recommend automating the process. The easier we make it for our users to follow best practices and corporate policies, the more likely they are to follow them, which in turn leads to higher security morale and a stronger security culture. The more buy-in you get from your users, they support you, you're supporting their smooth security controls, and we're not just a blocker in their chain of trying to do their job. Remove unnecessary credentials. Maybe set up a report to run every 30, 60, or 90 days that someone reviews to verify if the access is still needed. Like if we're looking at all of our access and we see, hey, this permission or this user has not accessed this service in 190 days, why do they still need those permissions? Maybe that's a good opportunity to start pulling back a little bit on the permissions so we're not overextended. Or if a user leaves, what are we doing to audit and make sure that we don't still have access that for folks that just don't need access to the server or the service anymore because they're gone, or maybe they changed permissions, or maybe it was only temporary access that they needed in the first place. So having a look at that, disabling them. If you could, again, another automation piece, if you can automate the removal or disabling of credentials after so many days of inactivity, that's another good thing too. And delete any access keys that haven't been used. Again, it's all about reducing the window of exposure with that, removing the permissions, deleting the access keys, making sure that folks are not overextended or the permissions are not overextended. And then monitor for all of this stuff. Really, prevention is ideal, but detection is a must, right? We've probably, a lot of us have heard that before from our friend Dr. Eric Cole. But we need to monitor and alert on this stuff. We want to be notified of any violations of some of these best practices and maybe policies that we've put in play. As far as CIS Foundations, AWS Foundations, the whole first section is dedicated to identity and access management. So I know I just covered a lot of these already, which should further support the quality of these recommendations coming from our friends at CIS. I'm just saying it's a good place to start when looking to build the controls part of your cloud security program. What are other people doing? Well, other people are following, other organizations are taking the lead from CIS, from NIST, from SANS, and other folks to make sure that we're setting ourselves up for success. So, all right, let's run through a few of these real quick. Again, we've got lots of them. I specifically called out several by the bullet point. Again, version 1.3. Don't use root. That's the very first one. Just don't use it if you don't need it. Set a quality password policy. Force MFA for every management console login. Put all your users in a group. Don't set up access keys during initial IAM user setup. This is a good one. I want to touch on this one just a little bit further. When you create a user in IAM, you have the option to give them console login access and or programmatic access. If the user creation is not specifically for programmatic access and that's all they're going to be using it for, don't create keys at the setup. Make them create their own keys or request their own keys. What that does is it forces the user to be deliberate about what they need versus potentially having access keys sitting around for 30, 60, however many days that are never used. And before you know it, you've got active keys that maybe are several thousand days old. How many years in 2,000 days? I don't know, but that's really what we're trying to avoid more than anything else on that one. Use roles. So moving on, use roles, not users for service accounts. And then here's a new service, use IAM Access Analyzer. That's a newer service. This Access Analyzer, if you haven't taken a look at it yet, is really top-notch and very user-friendly. If you put that in front of some of your security analysts and task them with, hey, review the reports, create a plan, make a suggestion of where we can carve this up and peel back on our permissions and get more in line with that least privilege focus that you're working towards. A couple more CIS Foundation benchmarks for IAM. Again, it's not just the first section. We've got other stuff we want to talk about. I mentioned monitoring and alerting. Ensure you have a log metric filter and an alarm that exists for management console logins without MFA. It's also a pretty good idea to alert if someone logs in as root, especially if your written corporate policy says no one should log in as root except for specific approved circumstances. It's really easy to identify that rogue behavior when your policy says no and your alerts, your monitoring and alerts are accounting for that and triggering on that. And then the fourth one, 4.4, is IAM policy changes. If someone makes a change or a change to a policy, an IAM policy, those are your permissions. If changes are made to the permissions for a user, a group, a policy, you definitely want to know about that too. Hopefully you have a ticket for it and your infrastructure team has gone through the change management process if you have one, or they've discussed it with your security team and you already know about it and you can just ignore the alert. But if they don't, we want to investigate that and understand why we're making changes to policies and permissions. All right, another one. So IAM, again, big category. It's arguably one of the most important and most used services. EC2 is another top one. EC2 is Amazon Elastic Compute Cloud, or EC2, and it provides secure, resizable compute capacity in the cloud. It is reliable, scalable, and on demand, which makes it incredibly useful for a cloud environment. That's almost, the exact definition of a cloud service. What is cloud? Scalable, elastic, on demand. So what else? You can increase or decrease capacity in minutes. Remember, if you have an on-premise server, it's really hard to increase your capacity when you're dealing with physical devices, physical machines. So scale within minutes, not hours or days. And their SLA commitment is 99.9% availability for each Amazon EC2 region. It's pretty good. I don't know how much that really equates to. I didn't do the math. These are your servers in AWS. I realize Elastic Cloud Compute may not easily translate to servers, but EC2 is your server in AWS. So what are some of the best practices? Here are my security recommendations for EC2. Harden and patch your instances. Don't forget, you're still responsible for supporting and maintaining the operating system and other software on the instance. Do you have a vulnerability and patching program or plan for your servers in AWS? Golden images are another good suggestion. Do you use golden images? Why not create your perfectly configured and hardened system and make a golden image of that server and use it as a baseline? Use that to build your other systems off of. And then do the same thing for various different workloads or use cases, because I get it, not all servers need to be the same. You've got different use cases, application A, system B, you know, whatever it is, they are going to have different types of required configurations and required services, but highly scalable. If we're going to scale up and down really fast, we want a core image that we base everything off of. That's a lot easier to manage. So then you can use that golden image to test your patching against as well for your patching policy. If all the testing goes well, you could maybe auto deploy those updates to production, you know, blue-green deployments. Lots of other use cases here that lends perfectly to infrastructure and as code and automation through CI/CD. So this is all great using golden images. It's so much easier to manage and control all of your systems from a single source of truth rather than each of the individual systems. So having to rely on a patching system or connect to and update your servers all individually when you have hundreds or thousands of them, it's a bit cumbersome, versus you test and maintain and patch your golden image, and then you deploy your golden image to your systems or your environments. Side note, all of this good stuff doesn't work if every one of your systems is a special snowflake. So what do? If all of your systems are special snowflakes? Start working on paring down those specialness, re-architecting your systems and your servers so that they work better for a cloud environment, a cloud infrastructure. Working in the cloud is different, fundamentally different than an on-premise environment. A couple other things with respects to EC2, security groups. They're virtual stateless firewalls in the cloud. They use least privilege, or you should use least privilege, meaning only configure them to allow access for what is specifically needed for the service, for that business service, and from the source that needs access to it. Don't leave it wide open for the whole world to access, unless it's, you know, port 80 or port 443. But other services, be specific. Focus on single IP addresses that need access, or other ways that you need to get private access to your systems. But the point is, again, least privilege. What are the ports, protocols, and services that need access to the instance, and only allow what is specifically needed to access and what's specifically expected for that service. A couple other things about security groups before I move on. So again, they act as a virtual firewall that control the traffic for one or more instances. And as such, security groups should only be created as needed. Again, back to with the specific rules that they need for the intended use case. By default, no inbound traffic is allowed until a rule is created allowing that traffic. So best practice for configuring is to add specific rules for the network protocol being used and the specific source IP address. that we are expecting it from. The only time you would want to consider acceptable to allow access globally, 0.0.0.0/0, that's global, would be for TCP/80 or 443. Those are web services, HTTP, HTTPS. We don't need to give global access to really any other service other than a website. And even that website, unless it is a publicly available website, you don't need to give global access to it if it's not supposed to be publicly available. A couple of services or ports that we should be extra careful on, though, still talking about those configurations, is SSH, RDP, various database management ports. Again, who are we giving access to manage those systems? So SSH, RDP, we don't want to leave those up globally. And then use IAM for EC2. Again, this goes back to using policies and roles to control access to your instances. Consider using STS, Secure Token Service, for temporary access if needed. That way, access keys aren't long-lived. You're not running the risk of having that key good for hundreds of days or a couple of years or longer, because STS keys, they're temporary. By default, I think they're only good for like an hour, but I think that's configurable. So temporary access is also a good solution, a good recommendation from a security perspective as well. Relevant CIS Foundation benchmarks. We've got use roles, not service accounts, again, 1.18. And then ensure your EBS volumes are encrypted. So encrypt your volumes. In the cloud and in EC2 specifically, a lot of times we don't have data that exists forever on those systems because we're using our databases or we've got our S3 buckets. And the volume on the actual server is just runtime. But still a good idea to encrypt it. And definitely, if you have data that's persistent on those volumes, you definitely want to have encryption. Encryption should be a default expectation in the cloud. You, again, do not manage the underlying hardware and infrastructure that's supporting the services. It's in the public cloud. Everything should be encrypted if you have the option available. And then last foundational benchmark has to deal with the security groups, which again explicitly talks about no security groups to allow global access to administrative ports. Up next, we have relational database service in AWS, RDS, relational database. This is a platform as a service. What does that mean? So platform as a service and RDS, high level, it means that you don't have to worry about or manage the underlying servers. AWS will handle the server stuff, all that server stuff for you, maintenance, patching, etc. You just need to pick the type of database that you want to use, do some configurations to make it your own, and then provide the data. I mean, you could spin up an EC2 instance and run a Microsoft SQL database installed on top of it, or MySQL or Postgres, Maria, or whatever. You could have your EC2 instance and install a database and manage all that yourself if you want. But why would you want to do that if you don't have to? Your use case might say or might be in line with that and do that. But if it's not, it's just one more thing that you need to account for and maintain in an already chaotic cloud environment, moving parts all over the place. So no, we don't need to do all that. Instead, we can focus our efforts on controlling the chaos. Try to control the chaos as much as possible. Use platform as a service, use database services if you can. Remember, everything here is a service. There are a lot of moving parts, and simplify where you can. So quick tips. Remember, You don't have to manage or secure the underlying server, so potentially you're already a step ahead from a security standpoint. Ensure that your instances are backed up or that the backups are enabled. Test your backups too, just as a side note. Disaster recovery, man, there's a number, I always hear that like we've got backups, but then when we try and restore, it's unsuccessful because no one's ever tested the backup. This isn't a conversation on disaster recovery, I get that, but have your backups, make sure you're taking snapshots, test them from time to time to make sure that you can redeploy when needed. Also, all of your databases should be encrypted. Again, in the cloud, encrypt your environment. Based on a 3-tier web application design, databases or database instances should never be publicly accessible. So make sure your databases are protected. They're not publicly available. Architect your infrastructure accordingly to account for that. And then also, I've seen mentions in a few different places that snapshots could be publicly accessible. So make sure that your snapshots are not publicly available. You might need to scan for that or double check some settings. But if I can get a copy of your snapshot, I can redeploy your application essentially, or your database, and potentially get all your bad things or your good things. On the topic of RDS, I would like to at least mention Aurora as well. This is a fully managed relational database engine that Amazon provides. This is their RDS basically, and it's compatible with MySQL and Postgres. So if you have an existing database on one of those two platforms, it lends for easy migration, or you can start up new. Several operational and security benefits to Aurora. It is built for high performance throughput and storage, high availability, and it's, again, one less layer that you have to manage and secure. That said, don't forget to control access through your groups and policies, and also using security groups. We still need to handle access management. We still need to account for encryption, especially TLS, making sure we're accounting for data at rest as well as data in transit. And here's a good one. Configure Secrets Manager to automatically rotate secrets for you through Aurora. You don't even have to worry about it anymore, because that rotation could create a stop in service or a gap in service, versus if it's happening automatically as part of the platform. Again, it's another thing you don't have to worry about or that you forget about. You can also retrieve the credentials from AWS Secrets Manager programmatically. Again, programmatic access, you're managing your secrets carefully versus hard coding or other maybe not so good ideas. All right, I think S3 is the last topic for today. S3 is secure by design. It is private by default, and it's very easy to use. S3, let me go back real quick, make sure I didn't skip anything. Yeah, S3 is a storage service, object-based storage. Remember, cloud service providers want people and companies to use their stuff. So it makes sense that it is really easy to use. However, make no mistake, it takes a bit of effort, planning, and forethought to really do it well and safe and secure, because we don't want to just create a bucket and leave it open for the world without encryption. Oh, by the way, buckets are not encrypted by default in AWS like they are on some of the other public cloud services like Azure or GCP. So be careful with your encryption here. You've got different layers or levels of encryption that you can use. Again, risk-based approach, make sure you're using what is in line with your corporate policies and acceptable level of risk, whether it's simple server encryption or using KMS access keys or private customer-generated keys for that matter. You've got a few different options. You could encrypt the data locally before you even send it to S3 as well. Lots of options, but okay, let me back up slightly. So S3, secure by default, secure by design. But once we start configuring our buckets for various use cases, because we want to use it, right? It's not just somewhere we put stuff in and place and forget about. And people might need to be able to access it, other users, or maybe it's a static website that you want to host from S3. Yeah, you can host static websites from S3 as well. Insecure and other misconfigurations start happening and become pretty common, very common occurrence. An accidental data exposure results in completely preventable data breaches. We can prevent a lot of these accidental leakages by putting a little bit of forethought up front, making sure that we've got our encryption in place, who can access it, only the folks that need to access it or the sources versus being publicly available. Poorly controlled or configured S3 buckets are often the root cause behind many of the AWS related data breaches that we hear stories about. I'm not going to cover our beloved shared responsibility model here, but configuring your buckets for secure use is absolutely on the customer's side of the shared responsibility. If your buckets are not configured correctly, it's not AWS's fault. We as a society, as technology users, as security professionals, we should know that it's not the service provider. The cloud is not insecure if we didn't adequately control our buckets or secure our buckets. That's on us. Block all public access at the account level. S3 block public access is a set of security controls that ensures S3 buckets and objects do not have public access. You can set this at the account level so that no one can bypass those without you changing those settings. So global effects. It can impact all buckets in the account or at the bucket level and only impact objects in that bucket. So right now there's 4 different options for configuring those global settings, but use them. Tighten that down. Especially if you have other engineers or business units, software engineers versus your operations folks. They might be making tweaks to buckets and they may or may not really understand the consequences or the potential risk that may be happening or the threat that may come by opening that up. So protect it at the account level. And then once the settings are applied to the account, any existing or new buckets and objects associated with the account, they inherit those settings and further prevent public access. So it's not something you have to worry about for every single bucket, new and old. You do it once, anything from that point after will be impacted. And you should enable block public access for all accounts and all buckets that you do not want publicly accessible. If a bucket is being used for maybe hosting a static website, or there are certainly use cases where you need public accessibility for that bucket, I get it. There's absolutely that case. In that case, use CloudFront with signed URLs or signed cookies. And that way, this allows a user to, or it allows you to securely serve up private content through CloudFront, which is the content distribution network, CDN. And how that is helpful is that the user, the consumer, connects to the CloudFront, and then the CloudFront connects to S3. The public world is no longer having direct access or contact with the S3 bucket. Consider S3, honestly, like any other server. Would you want the public to have direct access to your server? No, you don't. Have them connect to the CloudFront or access using those signed URLs and signed cookies. There are different use cases for both of those, and what might be more appropriate in different scenarios. So I would check out the link I have listed on here regarding S3 security and learning more about signed cookies and URLs. Encryption is another big thing. Again, I've talked about this already throughout various stages, but default encryption ensures that all objects placed in the bucket are encrypted at rest once they are uploaded to the bucket. Since the company does not own the hardware that the data is stored on in a public cloud environment, encryption is a must. However, wherever possible, in case a hard drive is seized, maybe here's why we want to encrypt by default. If the hard drive on that server or those S3s are otherwise compromised, or stolen or confiscated by law enforcement, we know that our data is protected, and even if it's taken away, it's still protected. You can also force SSL. So again, when we're talking about encryption in transit, force SSL connections, which basically what you're doing is you reject anything that is not coming over HTTPS. Couple other things, make sure you enable server access logging, object level logging, so both server and object, and versioning. I love versioning. It's a means of keeping multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every version of every object stored in your S3 bucket. With versioning, you can easily recover from unintended user actions and application failures. I have had instances where programmers and cloud engineers have said, man, I deleted that and I wish that we had versioning because then I wouldn't have had to go back and recreate everything. And it just kind of, it's like when your computer crashes the week before finals and you're 90% done with your report and you didn't have a backup of your backup. Same kind of situation. Last thing I like to mention here with S3, it's not really security specific, but a good operational practice and cost saver. Use lifecycle management on your data in your bucket so that your data is stored as cost effectively as possible. What do I mean by that? Automate the transitioning of data from regular S3 to infrequent access, S3IA, infrequent access, and then to Glacier after a certain amount of time, and then expire the data. You don't need to keep the data forever unless that is the specific use case for that data. But again, going through that lifecycle management policy based on your needs will save a lot of money. I've had folks say, hey, I've had database engineers or DBAs say, hey, once we turn on that lifecycle management, we saved like $40,000 a month because we didn't realize that we were holding on to all this data that we didn't really need anymore. And it was mind-blowing experience for that user. Last bullet on there, use Access Analyzer for S3, very similar to the IAM Access Analyzer, just this one's more for S3 purposes. CIS Foundations benchmarks relating to S3, block public access, use encryption at rest and in transit. With respects to logging, we want to ensure S3 bucket access logging is enabled, so server access logging. Remember, it's a server, and you want to make sure that we're using CloudTrail associated with that too. Ensure that object level logging for write events, WRITE, not RIGHT. And then also you want to log for object level logging if possible, like if your use case finds it useful to account for object level logging for reading events is enabled. And then ensure you have a log metric filter and alarm set for S3 bucket policy changes. So same thing with IAM. If someone makes a change to your S3 bucket, you want to know about it. If someone makes a change to your security group, you want to know about that. I realize that's not something that we covered, but I figured I'd mention that here as well, since changes to policies could be an indication of, or an indicator of compromise, and we definitely want to be alerted when that happens. So I just covered a lot, I think, and covered some of the most used AWS services, and I think the must-haves from a security perspective. Again, go beyond, use what's appropriate for your use case, but I believe that these are some of the, the table stakes for good security posture in AWS and the cloud in general. So with that, I'd like to take just a few minutes to end things today by bringing your attention to some AWS services that you might not have heard of, or maybe you haven't considered for whatever reason you didn't think about it. But with many of our workforces moving remote last year and likely to continue to be this way or that way for the foreseeable future, lots of organizations have adopted, we will be permanently remote for maybe ever. Folks are selling off their properties and their land and or campuses. So remote workforce is going to be here. So I want to bring these couple to your attention. Again, thinking from a security standpoint, thinking from a cloud services, what are some good services? I've done some research recently, and Amazon Workspaces, I think, is a good one to check out, as well as Amazon AppStream 2.0. Workspaces is a managed, secure desktop as a service, DaaS, desktop as a service solution. Maybe you don't like the idea of virtual desktop environments. Maybe you're concerned about speed and performance. I get it. Or your data is somewhere else and not on the computer. I get it. But consider this for a moment before you disregard it. Do you have complete control over the local networks of all of your employees? I don't know if my company is controlling my network at home. I do know they're not, but whatever. So do you have control over your employees' networks? You don't. Are you using VPNs? Maybe. Do you still have a good patching program for your remote workforce on their endpoints? Are you patching their network gear or making sure that they are patching their network gear, their home routers, firewalls, etc.? Do they have control over their local, their Wi-Fi access? We don't, as a corporate or as an organization, as a company, I don't have control over the Wi-Fi of my employees at home. So I don't know who else may or may not be on that local environment. So things to think about. Or what about the software employees have installed on their computers that they work from for work? Here's another thought. Are they using their personal devices for work or corporate issued devices? What are they using? Do you manage those devices? Are you patching? Are you sure patching is still happening and endpoint protection is dialed in? Their antivirus, endpoint protection as a whole. So with desktop as a service, you don't have to worry about all of that. The user connects to the desktop environment in AWS. It's in your VPC, in your account, using a secure high performance connection. So if they have wonky or spotty Wi-Fi, those network protocols they say that it provides a high performance connection that can account for instabilities. And also, you build your systems, you build the desktop environment systems to your specifications and baselines. You control it, you maintain it, you patch it if you want. And oh, by the way, the data exists and is processed in AWS, not the person's local computer. So you don't have to worry about the back and forth or where the user is in the world. If you're a remote workforce, a lot of companies are saying work from anywhere, I don't care. Well, that might matter when you deal with data moving across borders and different things like that. In this option, maybe you set up your desktop as a service in US West or US East, and it exists within the US, it exists within that VPC and not transversing across the way. If that's not enough, these systems get shut down when they're not in use, which not only saves money, but also greatly reduces the window of exposure compared to many systems that users never shut down. Think about it. When was the last time you shut down your computer at the end of the day? I don't know. Most of the people I work with, the only time that they ever, I hate to admit it, maybe I shouldn't say most of the time I work with, a lot of folks that I have worked with over the years, the only time they reboot their machine or turn it off is when they're rebooting after patching. So again, desktop as a service, that VDI, man, when it's not in use, shut it down. You're not paying for it. The attack surface doesn't exist, so your window of exposure is a lot smaller too. I'm running short on time, and I want to make sure that I have time for some questions. So I'll just mention AppStream real quick. This is similar to Workspaces, but more along the lines of if you just need to provide access to a desktop application, maybe like Salesforce or an internal application that you've provided, maybe CAD software, something like that. And you don't want it installed on the local user, but they need access to it. So you can use that. You can use AppStream 2.0 for a scenario like that. So I'll wrap up by saying I've already got a part 2 of this topic in the works. If you enjoyed what I've talked about today, found it useful, my part 2 will be more geared towards the DevSecOps side of the house, where I'll cover some of the top used AWS platform as a services, PaaS, and serverless services. So we'll include things like CloudFront, Lambda, Elastic Beanstalk. Again, those are all part of like the top 10 most used AWS services, but I figured I'd give some separation. And then like I did here, throwing in those hidden gems with the remote workforce, I'm also going to talk about in the part 2 with some recommended infrastructure as code options and developer tools that can really help with automating security testing in your DevOps pipelines, and all the tools that your DevOps teams are already used to using, like Jenkins, GitHub, GitLab, Ansible, Terraform, etc. So that's all I have for today. I want to thank everyone for joining me. I really appreciate it. Hope you found some of this material useful and started thinking about ways that you can continue to explore your journey as well. We've got lots of courses. This cloud security curriculum, man, I'm really impressed by the level of effort that's going into really building out this cloud space that we find ourselves in. We've got long courses, short courses for different use cases. So check those out. And with that, I want to open up to questions. Carol, if you have any questions that have come in and we'd like to discuss, please go right ahead.
Yeah, thanks, Jonathan. There are two here. So what are the must aspects of the proper KMS management in AWS?
Can you repeat that one more time?
Sure. They asked, what are the must aspects of the proper KMS management in AWS?
I'm not sure if we mean must used services in KMS. I'll have to take that one offline and circle back. I do apologize.
All right, no worries. The next one says, besides Access Analyzer, are there any other tools that would help manage, I believe it says IAM, in a large organization?
There is a policy generator report that you can run that will give you all of your access, all of your users, last time they've been used. But the Access Analyzer is actually takes that several steps further, and I do believe is one of your best cases from within AWS without looking at third-party commercial tools.
All right, well, that's all the questions I see. Thank you so much, Jonathan, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.